In Part C of Example 8.2, we are to use Table E in Appendix A to find the critical value for a right-tailed test with alpha equal to 0.005. So in Part C, alpha is 0.005. Remember that alpha is the area in the rejection region. We have a right-tailed test, which means then that the rejection region is to the right of the hypothesized parameter or the assumed parameter. Recall from the standardized normal distribution that the z-score right in the middle or right at the mean of the normal distribution is 0. So we're looking for a critical value or a z-score that corresponds to a place where we would have 0.005. Alpha is 0.005 up in this tail. So in other words, 0.5% of the distribution above this value, this critical value. In Table E, we recall that the body of the table contains those areas. Looking at the picture at the bottom, this shaded area represents these accumulated values. If 0.5% of the distribution exists above this critical value, that means that 0.995 or 1 minus 0.005 resides to the left. Now looking in the body of the table then for 0.995, we find 0.9949 at 2.57 and 0.9951 at 2.58. And both of these values have a difference of 0.0001 from 0.995. And halfway in between 2.57 and 2.58 would be 2.575. And at times you may encounter textbooks or references that use this z value for this position on the normal distribution. But in this textbook, we will use the value 2.58 as is most often used in order to reference this particular critical value where we have a one-tailed test, and in this case a right-tailed test, so a positive z-value, where we have 0.005 or 0.5% of the distribution in this tail.